The goal really is to walk you through kind of the journey that we've had from when I started this way, probably 7 to 10 years ago to where we are now, and kind of what's next, and how do we expose internet performance, right, to our non-technical users. So I think if somebody's having a problem, their Netflix is buffering, or they're having problems with their Teams call, way back when, the only real internet measurement tool that people had access to was a good old speed test, right? So that you go to speedtest.net or speedtest.xfinity.com and you run that test and you get a number. But people don't really understand what that means. There's a lot of things that can be slowing down your speed. 10 years ago, if you had a single laptop Ethernet wired into your modem, a speed test was a pretty good measurement of the performance you're getting. But in a multi-gig world where you have all kinds of stuff connected, you potentially have Wi-Fi extenders, you have old devices, new devices, there's way more going on. And so when I took over the speed test site, we had a survey, like, how satisfied are you with the results of your speed test? And what we found interesting was, the very dissatisfied all went away at 100 megs. And that was regardless of the speed tier the customer had. You had 100 meg service, no more dissatisfaction at 100. 400, happy at 100. A gig, happy at 100. We're like, what's that coming from? Like, why is everybody at 100? And what we realized was our gauge went to 100, right? So people have no idea what megabits mean, but if the gauge was full, I'm probably, getting something good. But, some people did know what their speed tiers were, and they're like, I pay for 1,000. Why is this only saying 250 megs? And, there's a lot of stuff that can go wrong. So we started with our website, we started introducing this gateway speed test, which measures the speed delivered by our network right to the gateway. And every time somebody would come to our website and run a web speed test, 5 minutes later, we'd go and run a speed test of their gateway to start understanding, like, what did my customer see, and like, what did we deliver to their gateway within that roughly the same time period. And what we found was pretty crazy. Like, they were seeing about 20% of the speed that we delivered. And so we're like, well, why is it so different, right? And at the higher the speed tier, like at 100 megs, you were roughly seeing the same thing. But when you got to the gig speeds, we were seeing, like, people were seeing 250 meg, 300 meg versus, hey, we're delivering 1100. So the analogy that I use is, the web speed test is like trying to measure how much electricity comes into your house from a socket in your house, right? Like, the real measurement of how much gets delivered is at the electrical box, right? And the fact that, 15 amp comes out of the socket doesn't necessarily mean there's a problem, especially in a world where, you have 20 connected devices, 30 connected devices, right? The reason why you have this large connection to your house is so you can power absolutely everything. So, if you're kind of intuitive, you can maybe deduce, like, okay, I saw this on the web test, I saw this in the gateway speed test. So we tried to explain this to customers a little bit. I'm scared to click. There we go. So we tried to explain the difference. We're like, hey, you've got this plan speed. Oops. You've got a plan speed that comes into your house. You've got what does this speed measure? So we were trying to explain why the speed test measurement you saw on our website was different than what you were paying for. And we're like, hey, it's all these factors. It's Wi-Fi. It's your old gateway. Like, there are many reasons other than Comcast is messing up that you would see something lower than your plan speed. And one of the things that was really interesting is we looked at devices, right? How those devices affected it. So what you see here, right? You go from iPhone 4, iPhone 6, 11, 15, and 17. So this is the Wi-Fi speeds that we measured for all of the different devices. So you can see, like, if you're on an iPhone 4, it's 2.4 only, right? Because it's blue, and you were probably only getting about 50 megs of speed over Wi-Fi. So if you have a gig speed and you're measuring from an iPhone 4, you're not very happy with the service. But as you can see, right, as Wi-Fi evolves, the speeds get faster and faster. And that red band, right, is really the introduction of the 6 gigahertz, right, which is really pushing us past those gig speeds. And with Wi-Fi 7 on the bottom, there's not a lot of measurements out there yet because there's not a lot of people that have the Wi-Fi 7 gateway and a Wi-Fi 7 device, but we're seeing speeds above 2 gig now on the Wi-Fi, right? So again, we tried to explain this to customers. So on our website, we had a tool that would fingerprint your device, so we actually know what device you're testing from. I will click again. So we would try to like identify which phone you were using and then go, hey, on this device, this is the kind of speeds you should be expecting, right? And we tried to introduce that. Again, not everybody understood this, but even if they did, I think the problem with all of this is that tells me the speed to the phone in my hand, right? And a lot of our customers think I pay for a gig, I should get a gig on every device, in every location, in my house, right? Just I pay for a gig, I should get a gig back by the pool, I should get a gig on every device. And so that's really hard. So what we also then introduced is this thing called Wi-Fi Blaster, which is a pseudo speed test within the home. So this sends UDP packets over Wi-Fi that get acknowledged, so we can count how many were acknowledged on from the Wi-Fi chip, basically, and we can estimate the speed to every device, right? Including your Nest thermostat, your fridge, and we get an estimated speed for every device, and we're like, great, now we have a full picture. Like maybe in this case, the reason your camera is poor is because the connection to your extender is poor. So this is how we tried to bring it to life. This is our current experience. So if I click here, you should see it. So this is what we call the whole home test, which combines all of these tests into one. So first we check for outages. Like we look at our network at a macro level. Are you having problems? Nope, no outage detected. Great. Let's go in now and test the speed. And what was interesting is when we first did this, we started by just showing them the gateway speed test. We're saying, hey, you're getting 1,000 megs. And they're like, well, wait, am I online? Is there an outage? Like when we introduced that explicit outage check ahead, all of a sudden customers were like, oh, great. They've confirmed I don't have an outage. Then they were more receptive to seeing the speed. And then we take every device and we run that mini speed test to every single device. And now you can see kind of a full picture of your network and the connections that they have. You can click in and see the results for each of them. So this is just running that test. I'm going to click forward here. So, a full snapshot of your internet in one simple test. And then, the other thing that we notice is like, when I ran a mini speed test to your Nest, it's not getting a lot of speed. So I couldn't just use speed as the measure. So we also said like, hey, the Nest thermostat doesn't need to do as much on the internet as, your 4K TV, your Xbox. And so we basically adjusted the level of speed and the quality of the connection for each device before we called it to be good, weak, or fair. So this had a much better, results with our customers. They can kind of see, oh, great, I'm having a good time. I wanted to show speed to every device, and I really tried. We went through like 6 rounds of research, but every time we would show a customer like, hey, your Xbox is getting 300 meg, they'd be like, yeah, but I pay for 1,000. And are like, that's more than enough speed, for gaming, maybe for downloading. Great. If you had 2 gigs, you could download that gig faster. And there are use cases for that. But I think most of the time it caused more pain, and customers were calling because they're like, I don't get my full speed. And then, we collect a ton of, metrics at the same time, right? We have channel utilization. We have the PHY rate you're on. We have the channel. We have noise floor. And so this can be used to help, troubleshoot any connection that we find and help guide them. But the problem with all of this was it's still just an estimation of the quality of the connection to the device, right? I have no idea what you're doing on that device. And if, for example, video chatting or HD video wasn't checked, now I have a fair result and they're calling me, even though all they're doing is email. Right? They're having a great time on the poor connection doing email, but they're calling because a lot of us are like, hey, everything has to be green in order for this to work. So we really kind of needed, a new metric, right? So, users consume applications. They don't consume networks or megabits. They don't understand latency in milliseconds like everybody here does. They just know, hey, is Netflix on my iPad working or not. And so that's why we really are going after a new metric. And the fundamental difficulty here is also how frequently end-to-end speeds and network like change. So if you think of Wi-Fi, you run 2 tests back to back, like somebody started a microwave. All of a sudden my speed's cut in half. The dog walked between me and the Xbox, right? He absorbed a little bit of the signal and my speeds go down. And so showing these numbers and the variability is really hard. And apps need more than just speed, right? So that's why we started looking, and again, this kind of shows how, at some point, speed is not all you need, right? Web page don't load any faster if you have more speed, but if you reduce that latency, you can reduce the load time of the page overall. And this is basically where we're now looking at this thing called quality of outcome as this new metric. And it's kind of a middle ground between quality of experience and quality of service, where quality of the experience is more like the customer's interpretation of the experience, how good is it, and the quality of service is really like just raw measurements. So the quality of outcome is like, what is the likelihood that the application I am using is without error, right? Like if I used kind of, this Teams call, what's the probability that that's perfect? What's the probability that I have a perfect gaming session? And so this is probably the most technical slide. And the way this quality of outcome measure works, and again, I am not the one that developed this. I am also not probably the expert, but they basically look at latency of all the packets, right? So, and they define requirements for that application. So I think latency is a good way to measure everything. Like packet loss is almost like infinite latency, and jitter is in latency. And so the way this works is it's a cumulative distribution function over some period of time for the packets arriving for that application. So let's say I have this Teams call. I've got packets that arrive. They arrive at different latencies. And what we're saying here, I think this is a gaming example, is that like 50% of them need to arrive in less than 50 milliseconds. And if that happens, like that's pretty good. And then like, hey, 90% of them should arrive within 100 milliseconds. And then like 99% should arrive, within 250. And again, these bands can be moved, and you can define, hey, how strict or lean you want this. And then basically wherever so here in this example, right, like the blue line is the cumulative distribution function, like we clear the 100%. So the 100 is the probability that this is flawless, and the 0 is the probability that this is completely useless. So as you watch this curve go up, wherever that intersects, so right here it's intersecting at about the 80% mark at the 99th percentile. So that's saying, hey, if it was above 100, then this would have a quality score of 100. So the worst intersection point is basically that quality of outcome score. So in this case, like you have an 80% probability due to the latency at the 99th percentile that this gaming session is flawless. So this is kind of the new metric. We're trialing it right now, but like, what does this mean for end users? I think it means I can start saying now, instead of, hey, that device has a good signal, I'm like, hey, your Teams call or your video call, your gaming session is this healthy, right? And so it's mapped to the applications. It's kind of objective, right? It's really based on statistics. And again, sometimes even in very good quality, there's always the chance that something will go wrong. And I guess for us, what it means is we also have kind of an objective measure. I think today I don't really know what customers are doing on the network. I don't know how well, right? I know, hey, the RSSI looks good on all their devices, or the RSSI looks bad here, or they have channel interference here, but with this measure, I now know, hey, there was a video call happening, and the probability that was a good video call is X. And I think the most important thing about this metric is it's composable, right? The composability. And what do I mean by that is the way this cumulative distribution function of latency is built is it probes different parts of the network. So it'll build a latency distribution for your access network, for your core, right? It'll look at latency in Wi-Fi, and then with some math, you can kind of combine all those latency distribution functions and start understanding where the latency is coming from, or what the biggest root cause might be. And so here, for example, like it's showing, hey, 50% of the lag is coming from Wi-Fi congestion. You have some Wi-Fi signal. There's some access variability. Maybe the server you're accessing is far. And so using this also helps guide us with what troubleshooting I might do, right? If the server's far, maybe we could say choose a closer server. But if there's congestion in the core network, there's not a lot that my customer can do. But for stuff like signal strength, hey, get an extender, move the gateway out from under the couch. So that there are things that they can do for some of these problems, and it really helps to guide, hey, this team call has this score and it's poor because of Wi-Fi signal, and the solution is X, right? I don't 100% know how this will all come to life yet. We're really playing around with this, but we did give it to a group of like 25 people to try to figure out like how they think of this. So we gave them a router with this on there. You can kind of see your applications and the scores over time. And we gave them a survey that said, hey, like, what do you think of this new metric? And so the results were like 86% felt that it accurately reflected their experience. As much as the next one hurts, 100% of people said it was better than Gateway speed test, or than the speed test that they've run. 86% that they liked that this was an independent kind of measure, and then 86% would recommend this QO tool. So this is kind of the learnings that we got in this trial. So what's up next for us really is trying to figure out, like, how do we scale this? Can we scale this? What makes sense to users? And like a probability might be really hard for somebody, for my mom to digest in terms of a Wi-Fi score. But I think we are looking with the UX teams to try to figure out, like, how do we show this? What will make sense to customers, and how can we really guide our users in troubleshooting their internet? So I think those are the main kind of the evolution that we have. So I'm happy to answer any questions that folks might have.
Thank you for this presentation. I'm Stuart Cheshire from Apple. I was excited when I saw the title, and I didn't know what you were going to say, so I was very interested to see what I would hear. So it was a great presentation. Thank you. I have a suggestion as you continue to spread this message with more people. You spent the first half of the talk talking about people running speed tests, and we've all been doing this for so long that we take it for granted and we forget, why do we even run the speed test? And it's because we think the speed test is a predictor of the quality of experience we'll have. And in the days of dial-up modems in the 90s, going from 1200 baud to 2400 to 48 to 96, that made a big difference in your experience calling the bulletin board or dialing AOL. So everybody assumed that throughput equals experience. And we carried on doing that, and we got DSL, and we got cable, and we got fiber, and the rates went 10 meg, 20 meg, 50 meg, 100 megabit per second, 200, 300. And at some point, it stopped making a difference. I know, I'd say around 100 megabits, we could debate. But for most of the stuff you do, including 4K video streaming, anything above 50 stops making much difference. And yet we had this inertia. We forgot to ask, why are we measuring the throughput? And we just kept measuring it. And this is borne out in your information that the customers are complaining, why is my device X not getting this many megabits? And the question is, why do you care? Like, why do you think it matters? And it's because we've been so ingrained. And I want to give credit to the brilliant Margaret Cullen, who gave me this great analogy. With cameras, we used to count megabits. It was all we obsessed about. How many megabits does the camera have? And we hit a point, and now we've become more enlightened, which is There are other things that matter: shutter lag, low light sensitivity, color accuracy, high dynamic range. When we buy a digital camera now, we look for a lot more than just that one number, how many megabits. And we need to figure out how to get the networking world similarly enlightened that the megabits don't matter anymore. The megapixels don't matter anymore. The question is, what else rounds out this offering to give a good experience?
Yes, thanks. I totally agree. I think the customers still do care some speeds because they're like, hey, am I getting what I pay for? So they do want to sometimes check on that. Again, to your point, they care because they think it, again, if I get a speed test at 900 and I pay for 1200, that is not the reason Netflix is buffering, right? Like, and sometimes people are like, oh, hey, this gateway speed test less than I play. Like, you have a 2 gig plan, and let's say I come in at 1900 meg. That's still faster than most people's connections that are 100% fine. But 100% agree. And I think like latency is one of the big things that we have that like really is making a big difference, and we're investing heavily in kind of understanding. And I think one of the things that's important is like some traffic is inherently latency sensitive while others are not, right? That Excel file in the email, whether it comes in 500 milliseconds later or a second later, not the end of the world, right? Your gaming, that video call, those things really do matter. And I think for our networks to start understanding, hey, these packets are latency sensitive and these ones are inherently not, and like the infrastructure kind of respecting that, I think will make a big difference.
Hi, I'm Marcus Hiller. I'm chair of the IPPM working group. So I am tremendously happy to see this presentation. The quality of outcome is a framework being specified by the IPPM. It just passed working group last call and has been passed on to the ISG for review. So it's really, really, I just want to start by thanking you for bringing this here. I'm so excited to see this relatively new work already being deployed and tested in your networks. And looking forward to see how it works on larger scales. Some questions I would have. So in this quality of outcome framework, you kind of specify these ranges of usefulness versus uselessness and so on, and that could be dependent on the type of application you're measuring. Are you working with application vendors to define these ranges or so on, or is it something you're estimating with your engineers locally in your company, or how are you kind of approaching this problem? That would be super interesting.
Is I'm the product guy, so I think they've defined it for some large categories. I think the framework itself is flexible, which I like, and you can define one band, you can find 5 bands. Everybody can define it differently. I think what will be interesting is ideally wherever you set them or however we set them, the score should feel like what I'm experiencing, right? Like the quality of outcome should match my quality of experience. And I don't know how fine-tuned, like right now we're trialing it. We're giving it to some of our employees to say like, hey, based on the bands that are there now, like, does that match? There's probably a whole process around how this gets better. But I think what's also interesting is we can publish this is like, hey, here is what we use to determine that. And then that way it's objective and here's what we do.
That sounds great. Whatever you learn and whenever you learn it, it would be really great if you want to come back to the IPPM working group sometime and kind of present your findings.
Okay.
That'd be great. But thanks again for doing this.
Awesome.
Sama to you, Dresden. So I'm not fully sure about the survey that you showed on one of the slides. Like, I believe other than the application, it's very much dependent on who the user is, who is actually participating in that survey and how big that size was, who was participating in that survey. For example, if I'm voting or I'm using that service, I might have a different set of criteria by which I would measure what you call as the true quality of experience.
Yep.
Than the person XYZ who was participating in that specific survey. So I would like to know a bit more about who were the people who were participating in that, how many people were participating in here, what were their backgrounds, what kind of application was considered there, and like what were the kind of criteria that you used and so on, such parameters. It would be very interesting to know that.
Got it. it was a small group. I'm not sure that we controlled for bias and all of that. I think I'm trying to get back to this slide, right? I think the quality of experience is really how I judge this application, right? That's kind of on the left. So if I'm watching TV, maybe I really care and I need 4K, and if it's not 4K, I'm not happy. But my mom at 720 also gives that a 10 out of 10, right? So to your point, the user does matter. I think what's, the quality of service on the other hand is just, this is how many megabits, this is what the latency was. What the quality of outcome is kind of that middle ground where the score is just based on the stats, right? Like how many packets arrived in X percent of time. I think what I was saying in that trial is ideally the score that we assign would correlate to quality of experience, but at least it's an objective, repeatable thing. If I use this criteria and there's that session, it will always kind of get the same score. Now, whether that score is a 90 or that score is a 30, at least it's the same score. And I think what we're trying to do is figure out, like for our average user, where do I set it so it feels to most people like it works. So again, it was a very small survey. There's only like 25 people in that initial one. I think we're going to put out survey, like right now it's still internal trials. It's like 20 engineers, very biased group. But I think as we start rolling this out, we want to collect it at scale and see like, what do the scores say? And then ideally we would pair that with a survey, although even like surveys are biased because I tend to answer, how was this team call? Poor. Like I never tend to answer this team's call was great. So there is a certain bias in even the surveying. So I don't know how we'll land on the final answer, but I think over time we'll figure out, hey, like these are the thresholds that most people agree is good.
Sure, thanks.
Greg White, Cable Labs. Thanks again for doing this presentation here. It's interesting to see the evolution of it. I'm a fan of the concept of quality of outcome, but similar to the other questioners, I'm just wondering how we validate that the number that we're showing to an end user is meaningful. It's the old adage, what gets measured gets
yeah, you can't affect what you don't measure. Yeah,
exactly. Yeah. So there's just that caution of going full bore towards some measurement, which we're not sure yet correlates to something important, and then metrics get defined around that, and milestones get written into your business processes that you must be beyond some of these goalposts, things like that. So,
and I guess we have this score. I think it is the best measurement that we have. How do I translate that to a user? I don't even know yet. Right. Is it 5 buckets? Is it red, green, yellow? I think that's what we have to go through, like user research and testing. Like I like that it goes from 91 to 87 to 86, and it updates frequently. So to me, as an engineer geek, like it feels real. But like, is the fact that it almost never gets to 100 really stressful for many people? Like that is also a possibility. Like one thing that we like about our gateway speed test is Comcast kind of over provisions everybody, right? So if you pay for a gig, we give you more than a gig. And then so oftentimes our speed test results ends at 117. So it's like 100, you got 117% of your plan, and people like love that because I'm over delivering. But like, should I map 80 to 100 and now you have an application score of 110, and that I don't think we figured that part out. I think we're trying to like get this out there. How does it map? We'll have lots of user research into how we bring this to life, but at least for the first time, we're not just looking at the connection to a device. We're looking at in the context of an application, this person's having a good or bad time, and the device might still come into play, right? Like he's having a poor video call. Oh, well, guess what? That device is on 2.4 and has low signal or has high interference. And so that can help guide our troubleshooting. But yeah, I don't know how we're going to show this yet.
Yeah. Well, I encourage you to think also about kind of doing some experiments about introducing network impairments, or in the context of a situation where network impairments exist, calculate the quality of outcome and have the user report, again, what their experience is.
Yeah, and I
See
think
what we
what's
can
nice
build
about the
for them.
Xfinity app, we got 10 million monthly users. So like being able to survey at scale, hopefully is something that we can do to like fine tune this.
Great, yeah. Thanks
I'm
again.
also worried about showing stuff that they can't fix. Congestion in the core network, great. Like what do I tell them to do, right? Like hang in there.
Hi there, Pete Resnick. So long ago learned to avoid customers because they do very surprising things. So I like working away from them. That said, some of the stuff you showed earlier where you said, well, you know, we tried this, show them what their particular devices are doing, what their particular apps are doing, and they weren't real thrilled with some of that. But as you said, some of that is really good troubleshooting tool. And I'm wondering, it would be really good troubleshooting tool for me and my brother, right?
Yep.
And I'm wondering if those tools are available generally, and whether, you know, I don't know that you have any particular bonus for giving these out beyond Comcast, but some of those tools are just generally interesting, like, ooh, I could push the button and it will do a UDP test on the local network to everything, and I can go, that's your problem right there. What are these things still around, and what are the possibility for you productizing some of these things?
So like the whole home test does run this test to all the devices. The result looks like the left-hand side. Under the hood is the right. There's an Easter egg that we don't publicize, but if you long press the Wi-Fi icon, you'll get this technician view. So if you want to play with this, the under the hood view is there. Yeah, I don't think we make it available like in a command or in a way to like, yeah. But you can go initiate it in the app, and then you can kind of see all the detailed results by holding the partially.
Rob Wilton. So I think it's a great presentation. I really think it's good the fact that you're sort of using the network and seeing it from a user's perspective. I think here we see it from an engineer's perspective the whole time. And I think that in terms of user experience, actually the internet's not necessarily that great, because it's either it sort of works or it doesn't work, and you never know really where the problem is. And it feels like you're solving some of this in terms of you're saying, if it's in your Wi-Fi network, we can tell you there's a problem here. If it's in our access network, then there's an issue here. But after that, I don't think you get much visibility. So I'm wondering whether we need to be doing more in terms of trying to integrate applications so that they can report whether the issue is being seen across the network and which part of the network they're seeing it, or within their data centers and things like that, and having that information shared between the network and the applications. So when a user when you get the application saying, I'm not working very well, you need to speak to the application provider, or you need to speak to your service provider, or it's in the core and it's just busy and actually there's nothing you can do. Because at the moment, the sort of visibility to the user is like, it's just not working, try turning a few things on and off, come back later, that sort of thing. So it's not a great experience. And then the other observation I want to make is that in some of the newer protocols that we've developed in the IETF, like Quick, we've pushed really hard on security and encryption. And I'm wondering whether some of those choices are going to degrade our ability to monitor the network and give the users a good experience, and whether we're getting that trade-off quite right or not.
Got it. On your first point, I think we have talked about looking, like not only with this, but even from our VSGs, like looking at, hey, you know, is service X only down on one house, or is it like the whole node, and that could be a network problem? Is it the whole area? Like, I'd love to be able to say it's not us, it's Netflix, right? Like during the Tyson fight, right? Like, hey, they run on my test, gateway speed test, good, the connection, the Wi-Fi connection, but like, we have looked at like, you know, stuff like down detector, is Netflix having problem? Like, how could you, we haven't wrapped that in yet, but I agree that like service health and would be super interesting to customers. And I'd love to be able to say it's not us, it's Netflix, right?
Because they're going to blame you. And
yeah.
It's like, nothing we could do.
Yeah, the Tyson fight was bad enough that they got blamed the next day, so we got off on that one. But like, but I agree. In general, I feel like one thing with Wi-Fi is it loses half its speed pretty quickly, right? You lose a spatial stream, you lose an MCS, and like speed gets cut in half. And one of the challenges I think people have is they'll have like an Apple TV or a Roku or something, and it works most of the time, but it's at like, it's getting 10 megs, right? Or 5 megs. And so they're like, it works. This is a good spot for my TV. And then all of a sudden, you know, Billy throws his school bag next to the gateway, and now I'm at 2 megs, and now it's buffering, and the blame goes to the network.
Yep.
Going like, this is a great spot. My Apple TV doesn't have problems normally. And really it's on the edge. So one of the things that we tried to do with Blaster is like, if we can get you good coverage and I can have those fire rates at like 1,000 or 800, even if I lose half the speed, 800, 400, 200, 100, 50, like I'm still good and there's a lot more resilience. So I think one of the things that this test was trying to do is really flag those devices on the edge, which you may think work now, but may not be as resilient. So like, I think the easiest thing to solve for us too, and the thing that customers can solve is like, change that gateway, get an extender, right? Don't stick them all in a drawer, right? Like a nice Faraday cage made of metal where you close the door. Like those are things that our customers can do. So yeah.
Thank you.
Hi, I'm Sanjay Mishra from Verizon. So I think this is really good that you're adding context to the absolute test, because we offer broadband home service, and I can really, your message was very much resonating with me, and adding context is so critical, because there's the challenge is to balance the absolute number versus the experience. And I can tell you with my own experience that when our installers go to the home, there's no control as to where they would end up placing the router. It's a customer decision.
Yep.
And customer says, well, you know what? I have a 3rd floor and I wanted to go in my basement. There's a closet in there. Put in the router in the closet. It's hidden and I don't want to see it. And that's it. Sure, the technician does exactly what the customer asked for. Now they go out on the TV on the 2nd floor and play Netflix on Wi-Fi on the TV, and they're saying it's buffering. You know, and my speed here, I just did a test and it's not 1 gig. And that's what I'm paying for. So the challenge is, how do you manage that? So I think this is very, very appropriate in terms of explaining, you're not solving the problem, but at least you're giving more context to the customer that, you know, yes, you do have a 1 gig connection. And rarely you would ever see the customer would go into the basement where they had this router installed, connect a PC on Ethernet and check the speed. And it'll probably come up at, you know, close to 1 gig if that's what they offered. But if that's what they signed up for. But if you're sitting in 2nd floor or the 3rd floor of your room, of your house, you're not going to get that. So this is very contextual. And I think this is very helpful. And the fact that you also had the test to show, is there an issue in the network? That's also very helpful for a customer. So I think this is something very good.
Yeah, I think the setup for it was like, hey, we check our network at large. We check the connection to your house. And then we've kind of established that foundation. Hey, the connection's good. Now let's look inside your house. I think they were a little bit more willing to work with us. And like my friends that put their gateway in the basement, I'm like, if you had to light your whole house with 1 light bulb, is that where you'd put it, right? Because like, and so I try to make them understand, oh yeah, maybe I should put it out and in the middle of the house.
Yes, and placement of the router is not even considered by customer, but that's one of the key thing as to where you're going to keep your router.
Yeah.
Thank you.
Thanks.
Hi, Mike Blanche. Thank you for a very interesting talk. Just a couple of thoughts. The psychology of the scoring, as you say, is very interesting. I'm reminded of the coffee shop loyalty club thing, where you get 10 stamps, then you get a free coffee, and they did some testing on this and found that having a card with 12 stamps, but the first 2 filled in, people felt better about that than they did with having a 10 card stamp with them all empty. So yeah, there's some psychology there. And the other part was similar to Rob's point about the kind of the application and the content side, and getting per service feedback on the performance of different services. And I know that some content providers do already provide some sort of aggregated, anonymized data to ISPs about performance of different bits of their network, like down to like the /24 kind of level. And it seems like it would be helpful for this, for some of that to perhaps be incorporated, or if there are ways of getting even more granular information while still preserving user privacy that can help feed into this.
Yeah, and I think I'd love to use our application performance, like our wireless set-top box, our streaming app, so it can tell our network, but this does not exist. I don't even know if we're looking into this, but one idea that I had was the idea that, like, if Netflix or any, like, YouTube or any video service sees its buffer kind of emptying, right? And hey, I have to go from 1080 to 720. Could it not access the network somehow and say, hey, is there anything going on? Could you potentially steer me? Did something change? Like, and I think it's in both of our interests, right? Both the video provider and the network, for the customer not to buffer. And like, maybe we have rules that say, don't steer when there's there's active traffic, or it's, don't steer unless it's going to make it 30% better. It's like, we do have some of those rules, and it's like, well, if the application's telling me I'm about to have a problem, maybe those thresholds should be lower and we should just steer it. And like, how could the apps and the network work together to provide the better service?
Sounds like we need an open standard for that.
Sounds like I'm at the right place.
Oh. Well, okay. I'm surprised by that honor. Rüdiger Volk, I have been a layer-free core network guy, and I very consciously put all the access stuff and the users on the far side of an architectural boundary in my network. This development is really nice and exciting. However, I'm looking at my local situation where actually, with customer protection in mind, the regulators have imposed essentially SLAs. If you offer a certain speed, that means something, and the regulator actually provides a speed test. And I think as a starting point, that makes sense. As a networking guy, I understand that, yes, that is completely not the whole story, but it is the only thing where you can say, well, okay, a well-defined SLA is there, and if you don't fulfill that, there are actually repercussions. Kind of actually getting to something like you are doing here, of course, is much more meaningful for the customers. It looks like actually relieving help desks from a lot of potential load. Well, okay, maybe actually the more informed customer will produce a different load. Kind of what I'm seeing is, for addressing the regulators' interest and actually the customer interest globally. I think you reported that from your test and survey, the marking for this should be independently provided was very high. And I combine that with Pete's question, well, okay, is such a thing going to be available? I think it would be a really good thing to get something like this publicly available and independently provided, whether by a regulator or someone completely unrelated, is open. But I think that's a direction that what you reported actually asks us to go. Thank you.
Thank you. I think that's all I had. Thanks, everyone.
Super, Eric. Thank you very much for that talk. That was an awesome talk, and I want it. For those who haven't opened all your goodies in your bag. I found in one of the little boxes there was this really awesome pumpkin tart. It was really good. So if you haven't found it yet, I'll take it. But if you want to keep it, eat it. It's really good. So thank you very much, and we'll see you all at IETF 125.
I think it's well, it's kind of, well, okay, open